image. There was a lot of speculations on social media, but I figure that either it's one of the moons, most likely one of the moons of Mars, or perhaps a very long exposure of 3I Atlas. But in all cases, it has nothing to do with the cylindrical shape of the source. It's more to do with the exposure being long and seeing many images of the source, one after the other, as it moves across the Martian sky.
In early October 2025, the red planet became the stage for something extraordinary. As the mysterious interstellar object 3I Atlas glided past Mars, two European spacecraft, the ExoMars Trace Gas Orbiter and Mars Express, found themselves just 30 million kilometers away from it. That's closer than any ESA mission had ever been to an interstellar visitor. Neither spacecraft was designed for this kind of mission. Their instruments were meant for studying Mars, not chasing cosmic travelers racing through the solar system. Yet now, they were facing a new challenge, capturing something faint, distant, and in motion. And against all odds, they tried. When the Color and Stereo Surface Imaging System, or CSIS, aboard ExoMars began taking its first long exposures, scientists held their breath. Then, there it was, a faint, glowing smudge, barely visible against the black backdrop of space. Slowly drifting downward across the frame, that soft blur wasn't the glitch or a trick of light. It was 3I Atlas itself, an object from another star system seen by human eyes for the first time. What the camera captured wasn't the solid body of the comet, but its coma, the misty halo of gas and dust that forms as sunlight warms its icy surface. The actual nucleus, a chunk of rock and ice only a few kilometers wide, remained hidden within that glow. Yet the coma, stretching thousands of kilometers across, shimmered faintly, proof that the sun was waking this traveler from its long frozen slumber in the dark between stars. As the comet drew closer to the sun, the heat began to vaporize its frozen gases, pushing out dust and forming that luminous envelope. Scientists tried to measure its full size, but the coma faded quickly into the background, its light too dim to define clearly. Most comets grow long, radiant tails stretching millions of kilometers, but 3I Atlas's tail was nowhere to be seen, at least not yet. The CSIS data suggested it was just beginning to form, too faint for the camera to catch, but promising something spectacular as the comet neared its perihelion, its closest approach to the sun, later that month. According to Nick Thomas, the principal investigator for CSIS, the challenge was enormous. It's between 10,000 and 100,000 times fainter than anything we normally photograph around Mars, he said. Over on Mars Express, things were even trickier. Its cameras took shorter exposures, just half a second each, compared to ExoMars's 5-second captures, making detection even harder. So far, 3I Atlas hadn't shown up in those frames, but scientists weren't giving up. They planned to stack hundreds of images together, layering them like puzzle pieces, hoping the comet's faint light would emerge from the cosmic noise. Both orbiters went a step further, attempting to record the spectrum of light coming from the comet, a fingerprint that could reveal its composition. Whether the data is strong enough remains to be seen, but researchers continue to analyze every pixel, every photon, in search of clues. Over the coming weeks, they'll keep refining the data, trying to uncover what this strange visitor is truly made of, and what secrets it carries from beyond our solar system. Then, on October 4th, 2025, something unexpected happened. One of NASA's Perseverance rover's navigation cameras, not even built for astronomy, caught a fleeting, glowing streak across the Martian night sky. It wasn't a shooting star or a satellite. It was the same mysterious visitor, 3I Atlas, silently tracing its path past Mars, watched by robotic eyes from another world. The Perseverance rover's navcam isn't built for cosmic discovery. It's a rugged, practical camera designed to help the rover drive safely and navigate the treacherous Martian terrain. But on that quiet night above Guerrero Crater, as it swept its lens across the sky, something extraordinary happened. The camera caught a thin, glowing streak slicing through the Martian darkness, the unmistakable trail of interstellar comet 3I Atlas, passing within what scientists call cosmic shouting distance of Mars. The image was so striking that NASA quickly featured it as their official image of the week. At first glance, the streak looked almost too perfect, long, symmetrical, and precise, as though crafted by intelligent design. But could that really be the case? The NavCam, after all, was never meant to observe distant objects tens of millions of kilometers away. When it gazed at 3I Atlas, roughly 38 million kilometers from Mars during the flyby, each pixel of the image represented an enormous 12,000 kilometers of space. That's like trying to measure a grain of sand with a yardstick. The result? The glowing stripe appeared far longer than it truly was, a colossal 50,000 kilometers in apparent length, an illusion of scale that defied logic. Earlier readings from NASA's SPEAR-X mission had already placed an upper limit on the object's real size, no more than 46 kilometers across, assuming it reflects only about 4% of the sunlight that hits it. In other words, the NavCam image exaggerated the comet's size by over 1,000 times. If 3I Atlas really were that long, a colossal 50,000 kilometer concentrical cylinder, the Hubble Space Telescope would have easily spotted it back in July 2025, glowing vividly across the sky. But Hubble's data showed nothing of the sort. It appeared instead as a tiny, unresolved point of light, a mere spark against the vast black sea of space. So if the NavCam stripe wasn't the comet's true form, then what was it? The answer lies in the motion blur, the bane of astrophotography. To capture something so faint from Mars's surface, Perseverance's imaging team stacked hundreds of short exposures taken over several minutes. During that time, 3I Atlas was steadily moving against the background stars, leaving behind a trail of faint light, a cosmic brushstroke across the frame. What we're seeing isn't an object stretching across space, but light stretched across time.
Still, the image went viral almost instantly. Social media buzzed with theories and debates. Some users claimed the streak was evidence of alien technology, while others admired the poetic beauty of an interstellar traveler brushing past another planet. The best processed version of the image, refined by independent astrophotographers, has since surfaced online. You can find the link in the description below. Meanwhile, several orbiters, including the Mars Reconnaissance Orbiter, were also tracking the same patch of sky that night. For a brief window in history, 3I Atlas became one of the most closely observed interstellar visitors ever, captured simultaneously from orbit and the Martian surface. But the definitive data, the one that could settle the size and shape debate, didn't come from Perseverance at all. It came from HiRISE, the high-resolution camera aboard the Mars Reconnaissance Orbiter. With a resolution of about 30 kilometers per pixel, it's over 400 times sharper than NavCam's view. HiRISE's October 3rd observation could finally reveal the comet's true structure, or confirm that what we're seeing is something entirely unexpected. Yet, as the world waited for updates, something strange happened. A U.S. government shutdown froze NASA's public communications, silencing official channels right at the peak of the flyby. Researchers around the world found themselves cut off from real-time data just when humanity was watching one of the rarest events in cosmic history. The timing couldn't have been worse or more suspicious, as some skeptics noted. Speculation exploded online. Was 3I Atlas simply an unusually active comet, or something more extraordinary, an interstellar probe, a fragment of alien engineering, or perhaps a relic from a civilization beyond our stars? While most scientists remain cautious, the debate has ignited imaginations everywhere. Adding to the intrigue, on October 2nd, Perseverance recorded another streak during a multi-minute exposure. But this one didn't match the normal star trails caused by Mars's rotation. It cut diagonally across the sky, steady and deliberate, as if tracing a path of its own. It wasn't noise. It wasn't random. Whatever 3I Atlas is, comet, relic, or messenger, it's rewriting how we look at interstellar visitors. Caution, a word that seems to echo louder every time something extraordinary crosses our skies. NASA insists the data fits within the boundaries of known physics. Yet, between those boundaries, the silence grows heavier, because for every confirmed observation, a dozen questions remain unanswered. Why does 3I Atlas reflect light so inconsistently? Why does it lack a clear tail despite such intense solar exposure? And most puzzling of all, why does it maintain such stability when most comets of its size fracture under far less strain? As the JUICE mission races towards its intercept, scientists brace for the moment of truth. For weeks, ground-based telescopes will lose contact as the sun blocks our line of communication. That blackout window, though temporary, has already become a breeding ground for speculation online. Theories ranging from alien probes to rogue interstellar technology flooding social media faster than the data itself. Meanwhile, fragments of encrypted telemetry from Mars orbiters hint that additional images were captured during the flyby, possibly showing 3I Atlas in ultraviolet wavelengths. These could reveal whether the object's coma contains unusual materials, metals or compounds not normally associated with comets, but those files remain unreleased. For now, 3I Atlas continues its silent journey towards the sun, a faint blur across the stars, accelerating through our solar system, indifferent to the chaos it left behind. Whether it's a relic of another star system or something more, it has already rewritten how we see our cosmic neighborhood. Because if 3I Atlas really isn't a comet, then the universe may have just whispered something we were never meant to hear. Most astronomers still lean towards the idea that 3I Atlas is a natural object, not an artificial one, but the latest images reveal something fascinating. It's active. Around its core, there's a faint glow of coma, hinting that this interstellar visitor behaves like a comet. Yet for some scientists, the question goes beyond identity. They're wondering about its role in the cosmos. Could this lone wandering traveler have a purpose? Astrophysicist Suzanne Falsner proposes a bold and intriguing idea. What if 3I Atlas isn't just a rock, but a planet-making seed? Imagine a lone fragment journeying across light years, crashing into a young solar system and sparking the birth of a planet. Picture a newborn star at the center of a dusty ring, surrounded by swirling clouds of rock and dust, tiny grains twirling like smoke in a cosmic dance.
Over time, these grains stick together, forming pebbles, then boulders, then planetesimals, the building blocks of planets. Gradually, gravity gathers more material, and slowly, a planet begins to take shape. But here's the catch. Protoplanetary disks are fleeting. They last only a few million years before stellar winds blow away the gas, leaving a narrow window to form massive worlds like Jupiter or Saturn. Now imagine a game changer, an interstellar object crashing into this disk, already large enough to act as a planetary core. Instead of waiting millions of years for dust to coalesce, this cosmic visitor provides an instant seed, pulling in gas and material at a speed that could create a giant planet far faster than expected. Falsner's simulations support this possibility. She found that massive stars are more likely to capture interstellar objects, which aligns with observations showing that gas giants are indeed more common around bigger stars. The match is uncanny. Perhaps interstellar objects like Oumuamua, Borisov, and 3I ATLS aren't just lonely wanderers. They could be catalysts for planetary birth, jump-starting worlds across the galaxy. Some might have even influenced our own solar system's early history. It's a daring idea, still speculative, much like Avi Loeb's theories, because studying interstellar objects is notoriously tricky. They appear suddenly, move at breakneck speeds, and vanish almost as quickly. But this time, humanity is ready. We've spotted 3I ATLS early, giving our instruments a chance to capture its secrets before it slips away. For the first time, we might move beyond speculation and finally understand the true story of this extraordinary cosmic traveler.